Hey everyone, I'm Swati and welcome back to our series of mechanics. We are doing vectors and today's video is about analytical method of addition and subtraction, in which we will see how to calculate the resultant and the direction between two vectors, and we'll do some numericals on that. So let's begin with that. Okay, so let's start with analytical method for vector addition. Analytical method for vector addition, and this is same for both parallelogram law and triangular law. The basic mathematical expression and the derivation, everything is same. And I will do simultaneously for both, and you will see that comes out to be same for triangular and parallelogram law. So in the triangular law, you have seen that you have taken this as a vector, this is b vector, and that is your resultant r vector, which is a plus b, right? And in parallelogram, you have taken two vectors as two sides of a parallelogram. This is b vector, this is a vector, and this is your resultant. Okay, now what we are doing here, let's say if this is your b vector, this is also a b vector, right? The parallel line sides. Now in the last video, previous video, I have told you that the angle between two vectors should be between the two tips. So this is the head and this is the tip. So you have to extend this a vector here, and that would be the angle between two vectors, and you drop a perpendicular here. Similarly, you extend a vector here and drop a perpendicular here, and theta will be the angle between them. And this is your b vector, sorry. Right? So eventually, this diagram is same for both. This is your a vector, you extend it for both, and then this is your b vector, and this is the angle between both, as you can see, and this is your resultant vector. So the mathematical expression is also same. Now how to calculate its magnitude and direction we will see. So let's rename as A, B, C and D, and first we are calculating its magnitude. It's very easy. You can calculate its magnitude using Pythagoras theorem. You can say this is theta, so this side is basically B vector and cos theta. You can take this as cos theta is equals to base BC upon hypotenuse, that is BD. So that BC comes out to be BD cos theta, and BD is your B vector. So it is B vector cos theta. Similarly, DC comes out to be B vector sin theta. Okay? Using this. Like cos theta is equals to BC over BD, and sin theta is equals to DC over BD. DC over BD. Fine. So to calculate magnitude, we can use using Pythagoras theorem. Pythagoras theorem. You have to remember the result for your competitive exam and for numericals, but if you are in CBSE and for your school, you have to derive the derivation, and from whatever method they have asked, you can draw that diagram, write that statement, and follow this derivation the same for both. So using Pythagoras theorem, we can say that AD square, hypotenuse square, is equals to AC square plus DC square. Right? Now this AD can be written as R square, and this AC is AB plus BC. So AB is your A vector and Matlab this AC can be written as AB plus BC square. Okay, so this is A vector plus B vector cos theta whole square, and DC is what? B sin theta. So B sin theta whole square. Now since we are only calculating magnitude, so I just drop this vector thing and I'm only taking the magnitude. Okay, so now this can be open using identity A square plus B square plus 2AB. Okay, 2AB cos theta. This is the identity A plus B whole square plus B square sin square theta. Now you can take these together and be common. So you will get cos square theta plus sin square theta, that is 1 as per your triangular identity, plus what is this? Can you somebody comment me how I can remove these things from my iPad? Okay, so this is 1. Your r square comes out to be a square plus b square plus 2ab cos theta. So if you want to get the resultant between two vectors, now this is important, it is between two vectors a and b, and theta is the angle between them. Theta is the angle between vectors a and b, and this can be done for two vectors only. What if you have 3 and 4 vectors? That we have done in polygon law. So you have to take resultant of two vectors, then two vectors, then you can use third with its resultant, and so on. Okay, so next is direction. Because it's vector, so you have to calculate direction as well in terms of theta angle. So what you will do, see, this is my A vector, right? And that is my B vector, and that is my resultant. Now for the direction, always remember, that's a tip. If you have to find the direction of anything, so you have to take it with the horizontal. Now on horizontal, it is A vector, and this is the resultant. Then this is my net effect of A and B vectors. So this resultant should have an angle with the horizontal, that let's take it's beta, phi, anything. Let's take it phi because theta we have already taken. So that is the angle between your resultant, or you can say whatever the resultant of these two vector has a direction is from the horizontal. So now this is your B cos theta as we have already seen, and this thing is your B sin theta. Okay, so if this is phi, so you can say that tan phi is what? Perpendicular upon base. So perpendicular is B sin theta, and the base is A. Okay, for direction also you have to take the magnitude, and direction plus magnitude gives you the net resultant. So it is A plus B cos theta. So that phi angle, the direction, is your tan inverse B sin theta over A plus B cos theta. A plus B cos theta. So that is the direction of the resultant. Okay, so these two formulas are for both parallelogram and triangular law. That is the resultant between them. So what happened if let's take this case and do some cases. Your resultant comes out to be under root of a square plus b square plus 2ab cos theta. Okay, and your phi angle comes out to be tan inverse b sin theta over a plus b cos theta. Okay, so we are taking different cases. So first is, what if a and b are at 0 degree? That means theta is 0 degree, and your vectors are like this. This is a vector and this is your b vector. Then the resultant should also be like this. Okay, which is basically the sum of a plus b vector in the direction of this, and you can also check this from our expression. If you check the resultant here, then put theta to be 0 here. Then it is a square plus b square plus 2ab cos 0 degree. A square plus b square plus 2ab cos 0 degree. Cos 0 degree is 1. So this term becomes 2ab. It becomes a formula of a plus b whole square. And that comes out from the root as a plus b, which we have already considered as the resultant should be a vector plus b vector. For the magnitude, you have to simply add both the values, and that phi comes out to be what? B sine theta, sine 0 is 0. Okay. So it is basically tan inverse b sine theta. Theta is 0 degree, so sine 0 is 0. And over b cos theta is 1, though it is a plus b. So it comes out to be 0 degree. And tan inverse 0 is also 0, so phi is 0 angle. That means our resultant is also at 0 level. That means parallel to A and B. Okay. Next is theta is 90 degree. If your theta is 90 degree, means your vectors are orthogonal. So in that case, if one vector is here, A, and other is there, so your resultant would be what? R is equals to under root of a square plus b square plus 2ab cos 90 degree, and cos 90 is 0. So it is a square plus b square plus 2ab cos 90 degree. Cos 90 is 0. This whole terms will be 0. And your resultant comes out to be a square plus b square only. A square plus b square. Okay. And since 90 degrees, so your angle phi should be what? It is tan inverse b sine theta over a plus b cos theta. Okay, so if theta is 90 degrees, so sine 90 is 1 and cos 90 is 0. So this comes to be 1 and this goes to 0. So your phi is basically tan inverse b vector upon a vector. And that is obvious. B is perpendicular, A is horizontal, so tan is perpendicular upon base. So that comes out to be like that. Third is if theta is 180 degree. Now if theta is 180 degree, that means opposite vectors. If one is here, then the other is in opposite sense. Like there. Okay. So here the resultant is basically the difference between the two, and the direction is in the direction of the larger one. So your resultant comes out to be under root, okay, we are talking about magnitude, a square plus b square plus 2ab cos 180 degree. 2ab cos 180 degree, and cos 180 degree is minus. So that comes out to be a square plus b square minus 2ab. That is the identity of a minus b whole square. Square plus b square minus 2ab. So your r is a minus b whole square. A minus b whole square, and from the root it is a minus b. Basically it is a higher minus lower, maximum value minus minimum value. That is a resultant. And for the theta angle, it is also comes out to be 0 degree. If you put sine 180 degree, then it is sin 180 is 0. So phi is also 0 degree, but you can say in the direction of larger magnitude. In the direction of larger vector. Fine. So these are the three cases of your resultant. So if you want to do it quick, so you have to remember, okay, 0, you don't have to do that resultant, and you can simply add the vectors and you can say, okay, the direction is in the direction of both the vectors. Next is subtraction. Analytical method of subtraction. So now subtraction is a very interesting thing. In this, you have to change the direction. For example, let's take a case. Let's take B vector to be here and A vector to be here. I'm taking the parallelogram thing, and it's same for triangular law. And this is your resultant. Now what happened here? In negative, you have to just change the direction. As we have discussed in our previous video, this is my resultant. Now if this is the angle between A and B, so for the negative, you have to take B to be here, that is minus B vector. Now the angle become what? 180 minus theta. So all you have to do, you have to change theta by 180 minus theta because the direction get opposite. So obviously the angle between 180 minus theta. So the resultant was earlier a square plus, okay, sorry. So the resultant was a square plus b square plus 2ab, a square plus b square. There is some glitch. 2ab cos theta, and here the theta become 180 minus theta. 180 minus theta, and 180 minus theta is in second quadrant where cos is negative, so it automatically become a square plus b square minus 2ab cos theta. A square plus b square minus 2ab cos theta, which is my resultant. And for the angle phi, again you have to put theta to be 180 minus theta, so it becomes tan inverse. It was b sin theta upon a plus b cos theta, so it becomes b sin 180 minus theta over a plus b cos 180 minus theta. Now you can see that sin 180 minus theta is in second quadrant where sin is positive but cos is negative, so that comes out to be tan inverse b sin theta, and your obviously angle don't change because it is 180. Sorry, the trigonometry ratios won't change. And this is a minus b cos theta. Okay, so for the negative, you have to change the angle. Okay, so this is the analytical methods, and now we'll do some numericals on that. So this is the part one video of this. In the second video, we'll also do some numericals on this, and then we'll move to something else, that is resolution of vectors and stuff like that. Okay, so let's do numericals. Okay, so this is the part one video in which we have discussed this analytical method and check the formula. The next video would be the part two video of this, in which we will do numericals. It's a complete numerical based. So stay tuned with me, and we'll meet you tomorrow. Till then, thank you for watching this video, and do like, share and subscribe for more such videos.